Aspire Strategy for .NET with Glenn Condron.
The Azure and DevOps podcast is a show for developers and DevOps professionals shipping software using the latest in .NET, Azure, AI, and DevOps. Listen on to learn how to increase quality, ship quickly, and operate well. The show is sponsored by ClearMeasure, a full-service software architecture and engineering firm. Find them at www.clearmeasure.com. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. I'm excited for a return guest on the show, Glenn Condron. He's a principal product manager for the app platform team within the developer division at Microsoft, and he focuses on .NET. Before joining Microsoft, he was a developer in Australia working for various government departments. He's been a speaker at so many different conferences and venues. If you just search his name, you'll find tons of recorded presentations. But I'm excited to get him back on the show. Glenn, how are you, sir?
I am good. One of my dubious claims to fame that my children are fans of is that if they tell their friends to put my name into Google, I am the name that comes up, which is amazing.
There's not a lot of competition.
There's not a lot of competition. It means that some conference talk is usually the first result for them. At least it was. I don't know. This was a little while ago. But yeah,
right,
I'm good.
Right.
How are you?
Yeah, I feel sorry for people named Bob Smith.
Yeah.
Although they're kind of incognito on the internet. So.
Yes, that is true. Yeah, I'm doing well. Thank you very much. And yeah, I'm Glenn. I am the PM product lead for .NET Platform. So just anything that's not tooling, basically, is my part of my role. All .NET runtime languages, C#, things like that. Yeah.
Awesome. So you've been on the show twice before, and we'll include a link to those in the show notes. But for listeners who are just getting to know who Glenn Condron is for the first time, you've been a computer programmer for a long time, and can you think, what is it about programming that just continues to energize you, where you love getting up and coming to work every day?
Yeah, I've thought about this before. David Fowler and I have debated it before in the past, questions like this. I also did martial arts when I was younger, a lot, and a few hobbies like that. There is and a few kind of creationist things. There are a few things that are as good at being at the intersection of creativity and mastery as software, where you can both express, you can make things that did not exist before wholesale. Like you can create things by sitting at a keyboard, and you can feel like you are achieving mastery of some skill and domain and thing that is amazing. And so martial arts has that aspect of kind of mastery, and as you practice 1,000 times to be able to do this, to get this, your hand to be within the 5 centimeters of where you're supposed to go. Programming is kind of similar in that you have this achieving this ability to get better and better at this craft that allows you to make things exist. I remember I've heard people who are woodworkers talk about the same thing and how they love it and how they go and they're able to create these things. And I feel like that is the same for me in that. And software was my venue to be able to work on something that allows me to build things, to create things, and feel like I am getting better at something all the time. And because it is so fluid, I feel like that mastery journey never ends, and that is attractive to me.
Oh, that's for sure. It never ends.
Yeah.
Because it keeps changing, and the materials are not constrained to normal physics like 2x4s and nails and screws.
Yeah, exactly. There's so many ways to build a chest, right? But exactly. And it is rapidly evolving, but also there is so many domains, and I think this is true in probably any of these fields. If you think that a field is simple, you probably don't understand it, is one of my catchphrases. You just don't. If you think it's simple to make a box out of wood, you've just never tried. There's also so many subdomains of the thing, right? I may be amazing at building, I don't know, a RESTful backend API that can scale to billions, and I understand all of those problems. I know how all of that is going to work. And then that will help me almost not at all if I'm going to go and build a platformer game, or I'm going to switch to in the browser Spa application or something like that, right? Like the subdomains in the field are also amazing. And by working on .NET, I get to work on this technology that is used for so many of those. And I have this week, today, I'm going to talk about, .NET running on these gaming consoles and gaming platforms, and then what we're doing to support that at the same time as I'm talking to some kind of hyperscale first party using C# in the cloud to do something, and another guy who's going to go and build some agent that is going to run on the cloud somewhere using Gen AI. So like the breadth of things that the technology I work on gets used for continues to amaze me at all times, right?
Yeah. It's got to be pretty special when you talk to developers everywhere and say, you know what? You're probably running a line of code that I wrote.
Yeah, quite possibly. Yeah. Hanselman used to say that, right? Like you've probably used code that I wrote. Yeah, that's cool.
Yeah, absolutely. So we've had other guests talking about Aspire, and that is in your group at Microsoft. But just so everyone understands, what is the breadth of your group and the problems that you think about every day?
Right. So I have .NET platform, which is kind of my PM team. We have the languages, so like C# and such, the runtime, and basically, and all of the libraries and experience, and that you have used if you work on .NET. So ASP.NET, EF, all of the things that make building a .NET app feel like a .NET app. What we do not have, and Aspire, because it grew out of our group, we kind of created it there. What we don't have is the kind of the SDK CLI part of .NET, or the Visual Studio Code, or the Visual Studio experiences. We help with and partner with and influence and co-design things with those teams, but we don't actually own that code. It's a different team. Therefore, I think about almost anything that impacts those layers. I think about and talk about the next C# feature that should be discussed, like, if I think back over the last few weeks, since .NET Conf, which just happened, I've talked about dependency injection, async DI, in fact, because it come up as a concern in some of our apps that we were looking at .NET Conf. I've talked about the C# unions in C# with MADS and why and what we were focusing on there. I've talked about gaming and Unity and how we're helping the runtime work in places where it needs to for gaming. We've talked a whole lot about cloud and AI, about deploying .NET versions to Azure, for example, and getting that available on the machines. We've talked about a lot of agent framework and generative AI stuff. How are people going to build agents? How are pro devs specifically? There's a lot of focus in the agent world on kind of low code, I guess, like YAML based agents. I'm gonna push some stuff together, and I've been trying to dig deep on but I'm a developer. I want to sit at a keyboard and write some code. What does it look like? Where does it go? How do I do this? Right? Those things I have talked about a bunch, and almost anything in between. We've also talked about data, the data ingestion pipeline that the folks on the data team have been looking at to try and get data into vector databases and stuff and process them in a big pipeline. We've talked about and tried to solve problems over there. So yeah, that's the thing. So languages, libraries, runtimes. That's the slice of the stack that I work with, and almost any concern in there I will have had some exposure to, even though I am not like a language designer like Mads or something, right? So
yeah. Well, that's a big scope.
Yeah, it's interesting and varied for sure.
Well, if I were to fast forward, some number of years, and I think about if there is one, what is the normal Visual Studio solution going to look like when you open up a Git? It's a .NET app. You clone Git repository, and I remember years and years ago, you pulled up a .NET 2 app and it looked a certain way. You put .NET 4.8 app looked a certain way, and then .NET 5.6. Okay, there were differences, and now it looks a certain way. Yeah. And with Aspire, there, you're kind of morphing and you're pushing the .NET industry in a different way, and you're saying there's a few things that should be different. There's some stress points. When you talk about those as a team, what types of things do you think about?
So there's a few things like that. I'm going to answer that question like concretely, but when we started working on this thing that became Aspire, we had these scenarios in mind that were super important to the cloud, and we thought super common. One of them that is really vivid in my mind is we had a slide that we gave to when we were telling like the bosses this thing, and it had on it every step required to use Redis in a .NET app. And I think there might have been about 14 steps on that slide. You have to find the package. You got to know the package. You got to get the client SDK, add the client SDK to DI, but what lifetime, know the threading model, know the like thread safetyness of that client in order to know whether, can it be a singleton? Is it not a singleton? I don't know. I'm just going to Google that and hope that the code that I copy and paste looks good. Right. You've got to worry about spinning it up on the local machine, like all the problems that Aspire now solves for you if you were to use Redis with Aspire. And that slide of like 12 or 13 concerns, it includes observability and such, we could collapse to one thing, right? Then, at the same time, as we were talking about just the job that the developers are doing today and how it integrates with ops people and how you get your app running on the cloud is super complex, and we need to do work deliberately to make it easier. And then I also had this vivid memory, this fed into the beginning of Aspire as well, of this developer lead, and he said, I've just taken a bet on .NET. There is other .NET at my company, but I've not done it before, and the teams closest to me have not. They are all Java, but like it's a mixed Java and .NET like company, right? So it was fine to pick either. And he said, it's not that the Lego pieces are there's too many of them or they're too complex or anything. It's that I don't know if this edifice I have built is going to collapse under its own weight tonight and wake me up. I don't know if these two NuGet packages are supposed to go together. Am I supposed to use JSON.NET with this other .NET thing, or are they like the same thing, or do they have some I don't know. I don't know what they're all supposed to do. And that scares me. Like, it keeps me up at night. This is the question I asked him, was like, what keeps you up at night? And it was this idea that I don't know what's supposed to go together. And I don't know if I'm going to do things like cause a cascading retry where there's an invisible set of everybody is retrying 7 times. So when the one error happens, it retries down here in a loop and then here in a loop and then here in a loop. And then your retry takes like 20 minutes, right? I don't know if I'm going to accidentally cause that. And so we wanted to solve a lot of those problems. We want to make it simple, and we want to be able to solve some of these like keeping me up at night problems that we were really hearing directly from engineering leads. And that kind of funneled into what became Aspire, but like it wasn't really what you think of today if you've looked at Aspire. That wasn't really what we were thinking at the time, but they were the things that fed into it that we've really tried to nail. So then as we progress through this problem space, how do we make it trivial? How do we make it easy to get on the right path for building an app for the cloud in C# today? How do we give you like defaults and opinions, and like how do we make sure you've got the right resiliency patterns set up by default? How do we make sure that you've got the right observability set up, like OTel by default for OTel all the things, right? How do we make sure all of this is easy and the debuggability is good? We ended up picking up this idea of kind of extreme ownership, where if it was to do with that problem, we would try to we needed to tackle it, we would. So we would go to places where we might not be comfortable going, like deployments historically, for example, right? Then at the same time as all of this was going on, I had to help a friend do Python homework for a data science course that he was doing. And like I've used Python on and off over the years a bunch, but I had this very strong takeaway as I helped him, and that strong takeaway was that this guy would never be able to learn C#. It was too much. But also, he was about a month away from a cliff that he was not going to be able to figure out with Python. That the deployment, so that Python was so good at the messing around experimentation. It was so far over here.
Getting started.
And C# was so good over here. And when Python tried to get here, it fell over. And when C# tried to get here, it fell over, right?
Yeah.
And so I had that problem in my brain, and I said to Damien, eventually, and I tried a few ways of trying to solve that. I wasted kind of probably a year or so, and then eventually said, Damien Edwards, who will probably be on the show at some point, I said, I need you to tackle this problem for me. And so what that resulted in is, and I went and got Jared, who is the Roslyn dev lead, and said, can put them together, Damien and Jared, and said, make some stuff happen and see if we can solve this problem. And so that produced file-based apps. So that gave us the ability to have a single C# file that you could run, that you just put some code in, and you're now rapidly approaching the point where when you combine that with things like minimal APIs and these other kind of different programming models, you can have a getting started that is just as easy, but scales far more smoothly to where you want to go, right?
Oh, I remember taking a Java class in the 90s, and I was running a Java file on a command line. And so it's been a long time coming.
Yeah, exactly. Right. And you could, anyway, we won't get into the well, technically you could always do it kind of arguments, because they're all kind of bullshit, but yeah. So now that I've meandered somewhat, getting to your actual question of what does it look like? I said, okay, so if you partner those two things together though, and you look at this reality of kind of multi-language apps, you've at least got a JavaScript front end, or you've got some JavaScript somewhere. Mm-hmm. You're mixing, or you've got Maui and and Blazor, they're multi-part and often multi-language applications. They're solution spaces. They've got those things. Multiple running processes. So then you're in this future where what a .NET repo looks like for that type of application, because we are focusing on kind of cloud type apps. It'd be different if we're talking about games or something, or just a mobile app or something, just in terms of not as many pieces, not just as in simple, for all my mobile app friends out there. It is, imagine if instead of, if all of your project assets were just apphost.cs. And so there is this root file that is C# that you can code in. You can write if statements in it. You can choose to make your when you run your app, be environment aware, or whatever you need to in order to be able to get your app to boot properly. And that almost anybody, as long as they've got .NET on their machine, can .NET run that repo and it runs. That is a world that I've been trying to push to. And it doesn't mean that CS projects have to not exist for everybody, or solution files have to not exist for everybody, but they should be able to be added when you need them. And not before. And that means they need to have a reason to exist, not just because they have always existed, and they should add some value and some demonstrative step. A very obvious one is once you need to start doing, an obvious one when we were initially designing file-based apps was when do you add the package? And maybe that's when you start dropping to CS projects, is when you start adding packages. That's fine, right? But we have at the moment this proliferation of kind of solution-based assets, which is meh. You have directory.props, you have solution files, you have CS projects, you have targets files, and there's a couple of other types of assets like this. Visual Studio and Visual Studio Code have their own kind of assets. So you have this proliferation of files that float around in your root of your application, and they make it very hard to be able to walk up to a repo and run it. And so a non-obvious side effect of Aspire that I want to try a few years from now to get to is and we started this journey when we started .NET. We talked about this same goal back when we first made .NET Run, was being able to walk up to a repo and just run it, and it would work. And we mostly succeeded at that for project level stuff, if you're just going to build and run your app. But what we've never succeeded with until Aspire is an actual real app, because you've got so many dependencies. And so a real quote that we had from a person who adopted Aspire is that they went from, I think it was weeks to onboard a new dev to they made their first PR at lunchtime.
Nice.
And that was because of the encoding of all of the dev environment was now in the app host. So instead of saying, here's the markdown file or the 5 markdown files, but we forgot to update that one, so go and ask Jeff how to install the thing to be able to make stuff work. Instead of that being your onboarding guide, it was go.net run this thing and then mess around and ask Copilot what the code does or something, and then see if you can go fix this trivial bug over here. And that is the dream, right? Being able to make that be true for everybody, that any kind of .NET repo you walk up to, even a kind of complex enterprisey one, you're going to be able to get it up and running fairly fast. You're going to be able to get your new person who you're not going to have to waste days or weeks even of your new engineer before they can start doing something of value into the project. And that all of that information, all of that tribal knowledge or ephemeral stuff is kind of encoded in the project, which means it's discoverable and source controlled and version controlled, and the ops guys can see that you added this dependency that they don't have a thing for anymore, and when and who and why, and all of these sorts of side benefits start to happen, but also in a way that feels approachable and not when you open it up, there's 4 billion files that you don't understand. I once, and this is the tension, is you want to be able to get to that enterprise solution, which I think we're getting to with Aspire, but then also make it that when I make a new application, I don't feel like I just had 3,000 books worth of YAML jammed down my throat or something, right? I once said that, I was joking at the time, but I once complained that when you create a .NET project, the only file you care about is the only one in a subfolder.
Oh,
because it's hidden away because you have a controllers folder or something where the actual code is. And then you have 7 other files that you don't care about at all, setting up your project and doing all this stuff. And they're the ones that you see. And then there's one where you actually want to go type. It's down here somewhere, underneath this thing. And so starting to try to get to a world where that becomes less the case and all of the things are either meaningful because we have better defaults within an Aspire type experience or some other experience that makes some of these opinions for you. Keeping the right layering so that you're making a good flexible stack that doesn't force anybody, doesn't railroad anybody down any of these things if that's not where they want to go. But then making it so that enterprises have faster onboarding time and faster into the cloud time. Time to cloud if you want to start a new solution. They have better defaults to build on so that they can be confident that they're standing on solid grounding, that we are learning from the teams at Microsoft and teams out there on what the right kind of things are. The resiliency stuff is one of the things that springs to mind here immediately, right? By default, if you do nothing with an Aspire application, you have OpenTelemetry and you have a set of default resiliency patterns for all communication between your patterns. If you do nothing. And those patterns have been looked at by a lot of people. So they're probably reasonable. You should still think about them and make sure they're suitable for you and your specific domain and tweak them and stuff. That's why we put them in as code and not as, we tried to make them more code easy. We tried to make it obvious with the service defaults project where to go to tweak them because we suspect a bunch of people are going to want to, but we know you're on this solid foundation. We want to continue that. But then, and then make this onboarding experience very fast, make this ability to get to the cloud be fast and good, and resolve that fear of the engineering manager doesn't know if this thing is going to come tumbling down because he's stuck together the 20 components and they feel like they're sticky taped together with 20 pages of YAML. He's got 5 config settings. He doesn't know what they do. We want to try and solve as much of that as we can. Make the repo not feel overwhelming when you create a new project. And get you to where you need to be. That's the thing. And so I expect to see more and more more and more projects that don't need a CS proj because they're just a C# file or have an apphost.cs be the Aspire root and then you Aspire run the solution and it runs. And I expect to see more and more solutions like that. And I hope that the more polyglot tool chains start to kind of unify a little bit under Aspire. So Aspire is not a .NET thing. Comes out of .NET. It comes out of .NET, but it is designed to be as well supported. We wanted to support JavaScript and Python and Java as well and natively as it does C#, right?
So
because so many of the audience are polyglot, right?
Well, if you clone a Node Git repository or a Java Git repository, and you say, oh, I'm using Aspire, what does that look like?
So Aspire CLI is just an AOT compiled .NET application. So you can grab the Aspire CLI and run it. You don't need .NET on your machine. And then you can, currently your app host needs to be a C# file. So you probably still need some like C# editing experience to be able to edit the C# file. Although we have experimented with a JavaScript one, where the app host file is a JavaScript file. We have also experimented with a Python where the app host file could be a Python file. If you were truly all JavaScript or all Python. But the sweet spot is still kind of .NET with one of these other languages, which is where we're growing out from. But we do increasingly have a few people who want to use it just that are all JavaScript, for example, and they want they want the same, all of the problems that Aspire solves are universal. None of them are unique to the C# ecosystem. We just chose to solve them in this way, right? And also, many of the .NET ecosystem, many of the .NET customers out there who are actually building real cloud apps are kind of polyglot-ish. They got a little bit of a couple of other languages, right? Even if it's not that much. And so you kind of have to do most of the work to be kind of truly polyglot anyway, even if all you ever want to do is support people who are building C# apps. However, what we thought we wanted to do was try and tackle making Aspire be truly universal and multi-language and work for JavaScript, a pure JavaScript app with all JavaScript front-end and back-end, just as well as it works for an app that is a .NET back-end with a C# front-end. And we got like a ways to go. Right on that front, we're not trying to like abandon all of the people that we're working with in order to get there. But we're like got that as a North Star where it is this truly multi-language developer solution that can be used in many ecosystems and ideally will be used in many ecosystems. Get people to the cloud faster, get people better dev in a loop for cloud, and probably increasingly AI apps. Now, when you see the Aspire dashboard, for example, has this feature where it kind of detects the generative AI calls and it gives you a slightly different like UI view where it pulls that data out of the OTel stream and shows it to you in a nice way. So you increasingly see things like that also make it nice for kind of AI stuff. Also, kind of by definition, agentic apps are kind of distributed because they end up with agents in many processes across a thing. And so like to some extent, this new wave of AI, if you're using it in your solution, you now have all the same problems of cloud multiplied by the non-determinism of LLMs. So like it's just worse for a dev in a loop standpoint. Yeah.
You've mentioned AI early, and there's so many different ways to put it together, but you've had a multi-decade career and seen just the explosion of database-backed custom applications where this software system owns a certain bit of data, certain workflows and processes around that data, and over time it has cropped up and gained some HTTP web services so that other systems can connect to it. And it seems that every single one of those systems out there on the planet is going to need an MCP server in order to be able to integrate and expose certain processes, workflows, data to whatever the company wants to do from chat interface or agent interaction. Every system's going to need an MCP server. And so when you look at that type, they're all going to need some type of data caching. So literally not every call, just denials of service the backend system. And so you look at these MCP servers like, oh, that's just another application. I need a data store. I need the process where the compute's going to happen. It needs a progression of non-production environments. It needs a production environment, that whole chain, just like every other application needs. And so what's missing with Aspire in order to get to the point where I can say, you know what, this is the skeleton that I want. Just get me up and going, including environments in Azure and deployments so that I can start writing that first code that actually integrates with that existing system.
So you mean, so I think what you're asking is what is missing to make it actually building an MCP and actually adding an MCP head to an existing system easy? Because right now it's god awful. Is that kind of what you were trying to say?
I think it's the same question, even if it was not even an MCP server. here's a new application. Right. And it needs environments. And let's say I made it easy. Well, I want to store the data in either Redis or Azure SQL, and I want to put it in Azure Container App. Just cookie cutter that only.
And so you said what is missing, and so I guess I would assert nothing is missing. Go make a new Aspire app. That's what it does right now. It gives you if you do the starter app, it gives you like a web app and an API and a Redis cache and I think a database. They're all spin up. They're all as components. You publish that thing. It goes to Azure Container Apps. They're all individual services. It's kind of setting you up for the cloud properly. The Aspire dashboard is in ACA. Like when you go to Azure Container Apps, they rehost and kind of slightly tailor the Aspire dashboard in the Container Apps production system. For example, it just that all exists. On MCP, you're maybe right? Like it's quite possible that the future is that all things that you want to be able to participate in some agent flow are going to need to be in MCP in order to make that real. It might be that in practice, a lot of people do custom tools that are not necessarily MCP for their thing. So it's not guaranteed, but it's but it's certainly possible. And so that's why, so I have a guy who works for me, Mike Kissler, and you could get him to come on the show as well if you want. He is on the OpenAPI board, the OpenAPI spec committee. He is also on the MCP committee. He was the guy we gave the task of getting the MCP library in .NET to be first tier. And we are, last I talked deeply about, I'm not 100% sure this is still true, but I believe C# is the most spec compliant MCP server SDK that exists because of that, because they're super tightly close to the MCP thing. But also, one of the other roles that Mike fills is he is on the Azure API breaking change board. So if you're if you've got an Azure API and you want to make changes, Mike is one of the people who sits on that committee and tells you you're crazy for trying to make a breaking change. So he's deeply familiar with APIs and how to build them and how to do the specs for them and how to really actually have an API run and exist at scale. And he is merging all of those skills into the MCP SDK, knowing full well that the people who are trying to do that are also the people who are going to have to look at this MCP thing, and they're going to have to figure out how this new client type for their APIs works. And that's what we've been doing. We're trying to make sure that MCP SDK allows you to get your data into this new kind of agent world as easy as possible, and that it makes sense and has the features you need. Now, it's not, there is a tension around how enterprise, there's a constant tension about something being simple versus needing to solve real, it's complex because the world is complex. And so there's lots of design work in trying to make the MCP SDK be real, and they're working through that and they're figuring it out, but it is evolving rapidly. The biggest complaint when it first came out, for example, is that its auth was real bad. It was just it was basically not fit for purpose for anything other than you doing things on your machine that you could probably do otherwise. But that's evolving now. It's possible that MCP may even become the way that one agent talks to another agent once you build these things, right? It could become A to A, or maybe A to A will be A to A. I don't know. Who knows? There's many protocols in this space that are also rapidly emerging, but MCP seems like the most solid, right? In terms of it has a very real concrete problem. Everybody knows that it's very obvious it's very obvious how it could fit into your architecture. As you said, if I own an API in my company and someone else is doing an AI project and they need my data, the easiest way for me to get that data to them is to write an MCP. And then if I have that MCP hosted at the same place where I have my API hosted, then this other team is going to be able to just add the ACP using standard MCP stuff. And then I don't have to care what they're doing or how they're doing it. Their thing is going to call me. But don't fall into the trap, though, of thinking that the endpoint, the tools you expose in your MCP should just one-to-one map to your HTTP APIs.
Right.
Because it'll just be bad. So at some point, at the moment, this will change as models evolve, right? But at the moment, once you get to 30 tools, maybe less, 15, 30, I don't know the exact number anymore. The LLM gets real bad. at picking them and deciding to call them. So if you are relying on the model to decide that it's going to call this tool to pull this data in to do whatever task is being asked to do, the more tools you have, eventually there's like a law of diminishing returns. At some point, you're going to start getting poor results, right? And so there is as much API design in choosing what tools you expose via MCP as there is in designing your RESTful API in the way that you would design your RESTful API today. It just is a different client type and a different model, and you need to think about it as such. And I've seen a few people who just took their existing API and threw it all into an MCP and said, here you go. And that thing did not work in practice for anybody. There's too many. The 400 tools. I don't even know what to do with that many of them, right?
Right.
So, you do need to think about the surface area. That's actually what makes the MCPs maybe slightly, maybe more attractive to an API author, is that you still maintain this control over how your thing is being exposed and projected into this world. Because the alternative is the person who is writing the AI thing, they're just going to do the same code that they would do today to decide how to call the APIs and what tools are going into their MCP. They maybe do a better job than you. They might not, though. And they certainly don't know your data or your domain as well as you do. And so there's certainly something to be said for the idea that you know your API really well. And therefore you should be, if other people are going to consume it, be thinking about and on the hook for how well this thing is projected into that world. And maybe you need to change some of your stuff. If that becomes your primary client, like all of the people who are calling your API are now LLMs, then maybe you should even be like really optimizing for what it is that they are going to do, right? Yeah.
Well, as we close up here, I think everybody, including your people, you and your people inside Microsoft, are kind of experimenting with Copilot and seeing what it can do in the various flavors. And certainly, every company tends to have template Git repositories, or the template of this thing that's just a skeleton of something. And with GitHub, you can just like, okay, there's a template repository. Let's start with this skeleton. But has anyone in your team been able to get Copilot with Aspire to just kind of narrate with the structure of an application? I want Redis, I want Web API, I want Azure Service Bus here, and then say, go ahead and create these three tiers of environments in Azure and stitch it together with GitHub Actions, and I'm going to lunch, just go ahead and make it happen.
So, yes, is the short answer to that question.
Nice.
There will be more done in this space is a medium answer, some of which aren't my projects. But there is one though that I can talk about because I think this is fairly concrete. There's a few kind of ideas for things that maybe we would ship, that we haven't talked about publicly, so I don't want to go into them, but would not surprise anybody that obviously people are trying to do that. An experiment we ran though, or have been running, is so currently the current state of LLMs, they are very bad at rule following and very good at pattern matching.
Yeah.
So they're good when you give them lots of examples, bad when you say do X, do not do Y, right?
Okay.
But if you give them lots of examples of X happening and not Y happening, they'll tend to always do X, right? So we currently, one of our hypotheses is we build experiences around the idea that you say what you want and it runs the Aspire template that we have today that creates you an Aspire application that has all the Aspire scaffolding in it. Then it goes from there because you've established the pattern. You've got, and it knows now it's an Aspire app. It knows how Aspire talks to each other. It knows how the client communication and stuff works. And it's got an example of that. And then it looks at that project and says, oh, you want me to take this project and then add this stuff that you said the thing was and go from there. And we've absolutely gotten way better results doing that than we have with just trying to one shot, make me an application. And we've got a couple of different directions that we could go. We could try and take that to make it real. And there is basically this tension with templates. So that'll happen more and more. Like increasingly, you saw like GitHub Spark and Lovable, all these like super products out there that people have that can do this. And that's going to keep getting better. And there'll probably be we will probably have some like dev focused stuff where maybe File New has the option like in Visual Studio and Friends to be able to create more full solutions. Aspire has its own kind of templating thing where you can go Aspire New and get like an Aspire solution that has a bunch of starter content in it. All those things will happen. Your dream, if what you just described was a dream, yes, that'll get better. Like we'll get more and more products to work on in that space. But also, not everybody wants that slop. Some people just want a nice, crisp project to actually start writing code in. And so you need to balance all of this work. Templates have always been a thing that served many masters. So they are about starting a new project once however periodically you get to start a new project in your job.
Right.
They're also about learning what the new features are, as much as people desperately wish it were not so. And they are about just kicking the tires for something or exploring a cool idea. And they are all those things. And sometimes all those things are completely at odds with each other in terms of what you would put into the template. So if I had a dream for generative AI and templates, it would be that the kicking the tires and learning stuff could get out of the template. So that the templates were like focused on one of the goals. And I think one of the goals that you would try to focus on would be the actual starting point, the kernel that you would definitely want that is common core to any type of project, right? Because you don't care kind of what the LLM generates when you're just kind of kicking the tires or exploring a new idea. If you wanted to try out the agent framework stuff that we talked about, if you're exploring this world and you're like, oh, this agent framework thing exists, let me go make what an agent is. Well, then you don't care if you can go and type in the text box and say, just make me an agent framework thing. I don't really care what it does. Just like, I just want to look at the code and I want to mess around with it and I want to try it. Then that being LLM generated is amazing. It cuts down on the amount of engineering that I have to put into making that be a real sample. It cuts down on the amount of stuff you have to delete if you're trying to create a new project that you actually want to go somewhere. And it allows potentially our templates to focus on the things that you definitely want when starting a real project. And for some people, they aren't comfortable with the idea of the LLM scaffolding lots of that initial stuff because it makes too much stuff. It gives you this big thing with lots of stuff, and there's maybe some bad decision buried somewhere in there. And at the moment, at least with the current generation of LLMs, I'm not super confident it's going to do a good job. And I'm not comfortable with that for all things. Some things I'm super good with that. I spent this weekend playing around making this like game and sending links to my friend to go and try it. That was fine. I've not even looked at that code. I don't care what it is.
Right. It works.
It works. But if you're not in a domain where that's okay, then sometimes you want to be a lot more careful. You either want to use the LLM on far smaller chunks, which is actually the way I tend to do it a lot more, is like do smaller things so that I can always just like verify it, or do it myself and then have it like adapting things over time and using the standard PR process so I can treat the LLM like a junior engineer as opposed to treating them like a god architect, right? And so maybe generative AI will allow us to slice this better so that these different use cases for what I want when I'm starting something up on a machine can be better kind of separated out, and you can get better results for each one of them as a consequence of that, I hope, because I don't want to. It's possible that AI will get so good that I will just be able to type in the text box and it will make everything far better than I ever could. Certainly not the reality today. And so we'll have to see where it goes. But it is, if AI only ever got as good as it is today, and it maybe got incrementally better, but didn't get like orders of magnitude better, then what I just described is where we would end up, where you end up with AI ways of creating projects, and that allows us to move things that we historically would have put into a template just to let you do that via the LLM. You could imagine a world where when I ship something new, some new library, we just shipped a data ingestion pipeline library, so we just shipped a preview of it. It's on the .NET blog. You could imagine a world where there is no template for that. It should be kind of weird for us to not have a new thing that you couldn't just go file new in Visual Studio, right?
Yeah.
You could imagine a world where I didn't ship a template for that, but I gave you like a markdown document in the blog post or in our docs and said, copy this markdown, paste it into Copilot and hit enter, and you will get a project to kick the tires with, right? And then
now, wouldn't you call
the
that an
actual template is
architect
different.
spec?
Maybe, could be. Yeah. And then the spec kit, there's a bunch of this stuff in this domain, right? But I'm trying to be high level because I know you'll get people who are deeper on for each of these things to talk about in the future. But yeah, like you could imagine a world where that's the way we start to ship things, so that if you're just kicking the tires, I don't need to go spend, time to engineer a specific template to try and tick all the boxes. And then, the person who actually wants to start a new project is annoyed by it. And the person who's learning is overwhelmed by it because there's too much stuff. But I had to put the stuff in order to be able to make it be real enough so that if you did deploy it to production, it wouldn't fall over. Like it's all like, it just serves it, because templates serve so many concerns, they are often bad at all of them. And it would be amazing if LLMs let me make it so that they could be so good for at least one of them. That'd be nice.
Right.
Yeah.
Well, if there's a good number of examples that use Aspire to stitch everything together, then there we go.
And
we have pattern matching.
The guideline, because Aspire is opinionated in how it does some things, the LLMs get very good very quickly at looking at your code base and saying, oh, I know how to add this new dependency. You say, okay, I'm going to add Redis, and you're already using SQL Server. It'll generally do a perfect job straight away of adding Redis to your solution and making it so the next time you run, Redis is there and Redis is the client library works and stuff like that. Having guardrails like that is kind of nice, and it does. Aspire already kind of helps you a lot, because ultimately LLMs are kind of modeled after humans. Anything that helps the humans tends to help LLMs. Because Aspire was designed to give you like a concrete way of registering, a patternized way of using these dependencies and having your application stitched together and then deployed. It usually means the LLM can do a better job of it as well. It also pushes more of that to compile time, where so even when it gets it wrong, because the build fails, it figures it out and then it fixes it, sometimes without you even noticing, because it just does the build in a loop and then fixes the bug. Whereas when it's YAML, it can't. So interestingly, I guess, pushing more things into compile time, I would hypothesize, helps the LLMs more, because the compile time errors are easy to get. They're trivial. All the coding agents tend to run build and run test really regularly without you even necessarily prompting them. And therefore, you can make it, if you can make it so that it knows at compile time that there's a problem here, then you've just now automatically increased the productivity of a coding agent massively.
Right.
In fact, there was a project internally for compile time DI that I was somewhat interested in, almost only for that reason. Because compile time RDI is actually like a kind of ridiculously hard problem. But if you could make it be compile time so that you know a compile time that not ridiculously hard. It's just like it's a hard problem, not ridiculously hard. But if you could make it so that at compile time, when the compiler knows that you forgot to register a thing that this other thing is trying to depend upon, then the LLM could fix that immediately for you without you even realizing. Right. And the LLM could realize that it forgot the extra line of code to add the thing. Right. So there's something to be said for using programming languages to do more stuff, just so that the Copilot could do a better job of figuring out when there's a mistake. Right. If you're using Copilot to assist you. Yeah.
Well, that's a pattern that so many development teams already have to do and have invariably this PowerShell script to, spin everything up locally and run a few tests that are essentially tracer bullets that just go through. And if something isn't connected right, the test is going to fail. Yeah,
somewhere the people who love Haskell are real happy right now. They're like, we've been telling you the whole time, everything compiler time compiler verifiable, right? Yeah.
Hey, the more it's the whole shift left concept. The faster we can find that there is a problem, the more time we save.
Yeah. So one of the things that I have, some of our people I have, these aren't actually directly in my team now, but one of the things that's being worked on at the moment is things like multi-threaded MS build and AOTing the .NET CLI. I can't remember the number, but if you have Chet on, he will tell it to you, or I could ping it to you after this if you want to put it in the notes or something. But if you add up all of the time spent running .NET build in the universe every day, it's huge. So if we can multi-thread MS build, or we can AOT to improve the cold start of the .NET CLI, even by a second or two, the actual amount of times that the .NET build is called every day means that even by shaving a second off of the time it takes for .NET boot saves a ridiculous amount of hours over the course of a day. And if we can multi-thread MS build, have MS build do be better at caching, maybe have a persistent MS build that stays running on your machine so that more stuff can stay in memory so that your builds are faster, that now gives you all of this room to be able to for things like this, where you can now start generating better results. There's an experiment we're running at the moment with build output, for example, where when you get an exception in your build output, showing you more of the code in the error. Like, this is where the error happened. Here's several lines of code above and below that to be able to help you narrow in. And that's probably useful for you as a human, but the actual thing we're testing is whether or not it means that the LLM can know how to fix that build error without having to pull more context in so that your context window can be more efficient because it knows how to fix it immediately. Yeah. Lots of things like that going on. And we could probably talk for another half an hour about things of where I give you like a 2-minute of like, let's talk about more like some other cool thing that we're doing, that we're thinking about. Async v2, for example, moving async out of the compiler and into the runtime, things like that.
Well, then we'll have to have you back on before too long because, we can go on for a long time to come. This is fun.
For sure.
This is fun. Wow. That's a lot of stuff, Glenn. So, your world, you're pretty busy, and you have an important team at Microsoft, and .NET developers everywhere are loving the advances. So I appreciate you coming on the show.
That's the goal. I hope they're all loving it. If not, they can tell you so you can tell me, and then we'll try and fix that.
Sure. Well, thanks again for coming back on the show and sharing with Aspire and AI and lots of good .NET advances. I appreciate it.
Yeah, no problems. Thank you. You all can, ping me, Twitter or something, I guess. Probably easy if you want. I'll put some contact. If we'll put some information in
we'll put it in the show notes.
If people want to contact me, but yeah.
Yeah, we'll include all that in the show notes. Listeners, you can just check it out wherever you're listening.
Yeah, thank you
Glenn,
very much.
Thanks so much. All right. And until next time, dear listener, keep shipping.
You've been listening to the Azure and DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and anywhere you get your podcasts. Visit our sponsor, ClearMeasure, at www.clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.